All right, this is a specific heat problem, and it's asking us to uh, calculate the specific heat of glass. And so we're going to need the formula. Q is mc delta T. So Q is the amount of heat energy, M is going to be the mass, C is the specific heat of the substance, delta T is the change in temperature. So let's start out by filling out what we know. So we know it is a 4-gram sample. That's going to be the mass. So we know it is 4 grams. We do not know the specific heat. That's what we're trying to solve for. So that's going to be our X. Okay. When you look at this, we're trying to determine the change in temperature, delta T. So it says that it started at 274 Kelvin, goes to 315 Kelvin. It actually tells you it's an increase of 40 Kelvin. So 40 Kelvin, notice the decimal because we're accurate to a Kelvin. And then, let's see, the amount of heat it absorbed, it says was 32 joules. So that goes over here. Basically, this is just rearranging and solving for X. So you need to get X by itself, which means you have to divide this side by 4 grams. You also have to divide this side by 40 Kelvin. So these cancel. Now it's time to punch this into your calculator. You type in 32 divided by 4 divided by 40, and your calculator is going to spit out this. Okay. For sig figs, notice this has 2 significant figures, this has 2 significant figures, this has 2 significant figures. Your answer should have 2, so you really should add a 0. Looking at the unit, it's joules per gram Kelvin. So that is your answer. Okay, in the next problem, another specific heat. This one's a little more complicated, and there's a couple of reasons why. First off, you're going to notice the amount of energy is given in kilojoules, but our specific heat capacity is listed only in joules, so we're going to have to do a conversion there. The other thing, looking at the formula, Q equals mc delta T, we need to know the mass. We don't know mass. We know a volume of water, but I did give you the density of water, which correlates its volume to its mass. And because this is liters and this is mils, we need to convert liters into milliliters. So let's start with that. We're going to start first with the 6.2 liters of water. Well, to make milliliters, I know every liter of water is 1,000 mils. Liters cancel. Multiply. That's going to give us, let's see, that's 6,200 milliliters. Okay, well, and we could have done this on the end of this fraction as well. We didn't have to do this step separate, but I don't know, I guess I just did it, which is fine. If you look at the density, it's 1 gram per milliliter, so I know every 1 milliliter of water weighs 1 gram. Mils cancel. So it's the exact same number, 6,200 grams of water. So now we know the mass of water. The other thing we're going to have to do is convert the heat from kilojoules into joules. And so let's start 980 kilojoules of heat energy. Well, I know for every 1 kilojoule, there are 1,000 joules. Kilo means 1,000. Kilojoules cancel. I multiply. That's going to be 980,000 joules, or you could write it as 9.8 times 10 to the 5th joules. Okay? So now we know the heat energy in joules. We know the mass in grams. So we're actually ready to start plugging into the formula. So like we said, we have 9.8 times 10 to the 5th joules is the heat. The mass we know is 6,200 grams. The specific heat of water was given in the problem, 4.18 joules per gram Kelvin. And then the change in temperature, delta T, we do not know. We know an initial temperature, but this is not the initial, this is the change. Delta means change. So we need to solve for this. We got to get X by itself. We're going to divide by 6,200 grams. We're going to divide by 4.18 joules per gram Kelvin. Okay, these go away. Joules are going to end up canceling. Grams will cancel. We're going to be left with Kelvin. And so if I solve for x, so take 9.85 EE, or excuse me, 9.8 EE5 divided by 6200 divided by 4.18, and you're going to get 38 Kelvin, which is our change in temperature. Okay, so now notice the problem is asking, what is the final temperature of the water? It didn't ask for the change, it asked for the final temp. Well, we know that the change in temperature is essentially the final temperature minus the initial temperature. And so we know the change was 38 Kelvin. We know the final temperature, we don't know it. That's what we're trying to solve for, because it wants to know what is the final temperature. The initial was given in the problem, and so that was 291 Kelvin. Well, to solve for x, add 291 Kelvin to each side. This goes away. X is, let's see, that is going to be 329 Kelvin.